Right, so this video is going to be adding or subtracting radicals. Now, when we multiply and divide, all that we need to have as the same is we need to have just a common index, the same index. When we're adding or subtracting, we need to have the same index and the same radicand. So when we have this square root, right, what's on the inside? So this x is referred to as our radicand. Right, and then this number here, the 2, the imaginary 2 there, not imaginary, but the 2 that's not written because it's understood, is called our index. Right, and then this symbol is our radical. All right, so when we are adding or subtracting fractions, everything has to be the same. So it needs to be the same index and the same radicand. So what's on our inside has to be exactly the same. Same thing when we're subtracting. It needs to be the exact same radical. So we need to have the same radicand and the same index. It needs to be identical. And then if they're identical, then all you need to do is, if you're adding, you just add the two numbers out front. All right, so you just do a plus b. And then if you're subtracting, you subtract the two numbers out front. All right, it makes sense. It's just like when it's adding x and 3x. When we do x plus 3x, well, here we have x. This is saying we have 3 of them, so it's x plus x plus x plus x. So here in total we have 4 x's. So we just add the numbers in front of our x's. Well, if I have the square root of 2 and I'm adding it with 3 times the square root of 2, this is telling me I have 3 of them. So it's a square root of 2 plus, the square root of 2 plus the square root of 2 plus the square root of 2. So this is saying I have 1, 2, 3, 4 of them. So I have 4 square root of 2, or I could add the 1 plus the 3, and then I times it by the square root of 2, and I get the answer. All right, so when it's a radical, everything has to be the same. The index and the radicand, they need to be identical. All right, so now we're going to go through a couple examples. All right, so it says, what is the simplified form of each expression? So we're adding and subtracting radicals here. So in order for us to do this, everything has to be the same, the index and the radicand. So when we look here, this is the square root of 7 and this is the square root of 5. So since they're not the same, we can't do anything with this. So this is in fact our simplified form. So that will be your final answer. It's just 6x squared times the square root of 7 plus 4x times the square root of 5. There's nothing that you can do there. All right, we're going to skip B for a second and we're going to go to C. So same thing with C. Here we have the cubed root of 7xy and the fifth root of 7xy. So yes, our radicands are exactly the same this time, but now we have different indexes or different indices. So that means they're not the same. So we can't do anything with this. So this is our final answer. So it'll be 12 times the cubed root of 7xy minus 8 times the fifth root of 7xy. So A and C, there's nothing that we can do. But for B, this is the square root of 5x and this is the square root of 5x. So since we have the exact same radical, the same index, the same radicand, everything is the same, we can then subtract the two numbers that are out front because we're doing 3 minus 2, and then we multiply it by the square root of 5x. 3 minus 2 is 1, so 1 times the square root of 5x. You don't have to write 1 because it's understood to be there when it's not, so we can just say the square root of 5x. All right, so that would be your final answer for that one. All right, now let me just go through one example real quick. I'm just going to add something to this, I'm going to rewrite this problem B. So if this said 3 times the square root of 5x minus 2x times the square root of 5x. So here we still have the same radical where they're both the index and radicand are both the same. So we could or we will combine the numbers out front. But since 3 and 2x are not like terms, this is how you would write your final answer. All right, so you would write it in parentheses 3 minus 2x times the square root of 5x. All right, so you would still rewrite it as 1, but you'll just put what you're subtracting in parentheses. So you just leave it at this point. All right, and now there's one more question that we're going to go through. So you may get a question like this, and at first glimpse you might say it's the square root of 12, square root of 75, and square root of 3, that none of those are the same, so it's impossible for you to simplify, and that's your answer. However, try and simplify your radicals as much as you can, and then see, does the simplest form match or not? So here, the square root of 12, since our index is 2, we would go back to our chart that we made before, and we would only look at our x squareds, and we would see, do any of these numbers divide evenly into 12? Well, 4 does. So we can rewrite the square root of 12 as the square root of 4 times 3. And then the square root of 4 is equal to 2, so it's 2 times the square root of 3. Same thing. Now here we will look for the square root of 75. So once again, we're going back here, looking at the square root again, or our perfect squares. And now we're going to go through and see, do any of these numbers divide evenly into 75? Well, they don't, but 25 does. So now we can rewrite the square root of 75. So we plus the square root of 75, which is now 25 times 3. And this is going to be equal to, the square root of 25 is 5, so it's plus 5 times the square root of 3. And now this last one, there's nothing that we can do. That's its most simplest form, so then it's minus the square root of 3. So now here, all of our indexes are all square they're all square roots, and our radicans are all 3's. So these are, in fact, like terms. So then now we can just add and subtract what's on the outside. So then this could be rewritten as 2 plus 5 minus 1, because that's what's understood to be there, times the square root of 3. 2 plus 5 is 7, minus 1 is 6, so it's 6 times the square root of 3. All right, so your first glance at this, you might say, oh, well, we can't do anything because the radicals aren't the same, the radicans are different. But you need to simplify as much as you can first before you can say if you can or can't do anything. All right, and that will be your final answer, and that is it for this video.